So this is week 1, day 2 video for Foundations of Algebra. So we'll look at linear applications and inequalities in one variable. So with this problem, we know that we've got a perimeter of a rectangle. We need length and width, and we want to find the length and width. So we know that we're going to use the perimeter equals 2L plus 2W formula, and we know that the perimeter is 16 times the width. So we know perimeter is 16W. We also know that the length is 12 more than the width. So now that we know these things, we're going to substitute. Notice that we have W's in both of these, so we're going to get everything into W's. So perimeter equals 16W, and the length is 2 times W plus 12, and then we'll finish up with adding 2W. So everything's in terms of W. 16W, distribute, 2W plus 24 plus 2W, so these are like terms now, so that's 4W. So 16W equals 4W plus 24. There's the only constant on this side, so we're going to subtract 4W since it's a positive 4W. So that'll be 12W equals 24. Divide by 12. W equals 2. So now we can look back here, and if W is 2, then length is 14. And perimeter is 16 times 2, or 32. And then the width is 2. So we've got a 2 by 14 with a perimeter of 32. The next one is a presidential race. So we've got Obama and Romney. So I'm just going to say X is Obama and Y is Romney. Of course, I could have flipped those around, said X is Romney and Y is Obama. Obama received 126 more votes than Romney. Obama did. So X is Obama, and he received 126 votes more than Romney. So let's say Romney had 100 votes. Well, 100 plus 126, Obama would have had 226. And Romney is what we have as Y. And so one thing we do know is that Obama plus Romney had a total of 538 electoral votes. How many did each candidate receive? So X is Obama, so we're going to substitute Y plus 126 for X plus Y equals 538. Like terms, Y and Y, that gives you 2Y plus 126 equals 538. Subtract 126, and you're going to get 412 equals 2Y. Divide both sides by 2. Y is 206. Who is Y? That's Romney. Add 126 to 206, and you're going to get 332, which would be for Obama. You add both of those together, and you're going to be at your total of 538. Here we've got the average cost of tuition at a public four-year university in 93-94 was $2,431. 20 years later, it's increased by 240%. So 240% divided by 100 is going to be 2 4/10. That is your growth factor. So what was the cost of this of going to a university 20 years later? So what we're going to do is take 2,431 and we're going to multiply it by this growth factor of 2 4/10. And when you do that, you're going to get $5,834.40. Now that's just how much it had increased. That's not your final answer. So what we need to do is we need to take from what it was, 2,431 in 1993, and we want to add the increase of $5,834.40, which would put us at 2013. When you add that together, you're going to get $8,265.40, and that would be the cost 20 years later. So here we see that Jennifer invested some money at 4.5% simple interest and $1,000 less than twice this amount at 3%. So what we're going to say is X is equal to 45 thousandths. Now where are we getting that number from? Well, that is 4.5%, and when you divide it by 100, that moves your decimal point to the left, because remember, percentages are out of 100. So that moves it to 45 hundredths. So there's your X. Now the other one is going to be at 3%. So when you do the same for 3% and divide by 100, you're going to be at 3 hundredths. So her total annual income from the interest was $1,020. So here's what we know. We know that 45 thousandths X plus 3 hundredths Y is equal to $1,020. All right. However, we do know that in the 4.5% simple interest, there was also $1,000 less than twice this amount at 3%. So what that means is, in place of Y, you've got $1,000 less than twice the amount at the 4.5%. There's your key right there, is it's 2x minus 1,000. So where does that go? That's going to go in the place of Y. So you're going to have 45 thousandths X plus 3 hundredths times 2x minus 1,000 is equal to 1,020. Everything's in terms of X. So what that's going to give us is just how much that was invested at the 4.5% interest. So we're going to distribute. So we'll get 3 hundredths times 2, so it'll give us 6 hundredths X minus, we're going to take 3 hundredths and multiply it by 1,000, and so that will give us 30, and then we've got the 1,020. So like terms are here. So we've got 45 thousandths plus 6 hundredths. So we should have 105 thousandths X minus 30 equals 1,020. So then we're going to add 30. So that'll be 1,050. And so when we take 1,050 and divide it by 105 thousandths, we're going to get X is 10,000. What does that mean? Well, that means that was how much was invested at the 4.5%. So for Y, that value is going to go right here. So now you're going to have 2 times 10,000, take away 1,000. So that'll be 20,000, take away 1,000. You're at 19,000 that you have invested in the 3%. So the last few examples, you can see that there's you're inserting something, it's a substitution, you're seeing distributive property, and you're having two variables, so we've got to get it into one variable in order to solve it. So we've got a chemist that must mix a certain amount, okay? So the chemist has 8 liters, okay? We know the liter amount of a 40% solution. So 40%, make that into a decimal. Now that chemist is mixing this with 70% with some. See, we don't know what it is, but we know it's at 70%. And to make just means to equal a 50% solution. Well, 50% solution of what? Well, that's your 8 liters plus your unknown to make your 50%. So 8 liters that we know at 40%. Some number amount of liters we don't know at 70%. And that together will be a 50% solution. So we should get 3 2/10 plus 7/10 x, and then we're just going to distribute. So half of 8 is 4, and then 50% of x. So we've got variables on both sides, so I'm just going to subtract the 5/10 x. So 3 2/10 plus 2/10 x is equal to 4. And then I'm going to subtract the 3 2/10. So that's going to be 2/10 x equals 2/10 there. And so when that should be 8/10, sorry about that. 4 minus 3 and 2/10. That should be 3 2/10. Let me just rewrite that. So this is 3 2/10 that I'm going to subtract, and that'll be 2/10 x equals 8/10. And then when I divide by 2/10, I'll get x equal 4 liters. So that 4 liters can be substituted here, can be substituted here. All right, how many liters, I don't know, of a 10% solution must be mixed with 10 liters of a 4% solution? So that, remember that 4% is just how many out of 100. You're dividing by 100, which gives you that 4 hundredths. And then to make, there's your equal, a solution that's 6%. Well, I don't know what that solution is, but I know it's x plus 10, and that's going to be at 6%. So let's multiply. That's going to be 1/10 x plus 4. 10 times 4 hundredths would be 4. And then 6 hundredths times x. And 6 hundredths times 10 would be 6/10. So we've got x times 1/10 is 1/10 x. 4 hundredths times 10 should be 4/10. And 6 hundredths times x is 6 hundredths x. And then 6 hundredths times 10 should be 6/10. So I'm going to subtract the 6/10 x. So that should be 4 hundredths x. We're going to subtract the 4/10, and that should be 2/10. So when you take 2/10 and divide it by 4/100, you should get x equal 5 liters. So 5 could be substituted here and here to find your answer. So we'll look at, all right, so next we'll look at some linear inequalities and intervals on the number line. So in context, we have a local club that charges $40, a one-time fee, $40, plus $35, and we're going to say per month for a membership. So we don't know how many months, because that's what it says. What's the maximum number of months can she belong to the health club? But she can spend no more than $355. So I can't spend $356, but I can spend $355 and I can spend $354. So I'm looking at everything below. So that means I can include $355. And so the inequality symbol is critical if you're going to look at your possible values. So we're going to subtract 40. So we're going to solve an inequality just like an equation. Inverse operations still apply. And so you've got $315 divided amongst 35. And so that should put you roughly around 9 months or less. Macy has scores of 78, 79, so 78 plus 79 plus 72 plus 73 on the first 4 exams, and she needs to take a 5th exam, and she would like to earn at least a C, which would be a 70%. Well, if you knew the 5th test, then you would know that you've got to divide, if you knew all those, you'd have to divide them by 5. So 78 plus 79 plus 72 plus 73 is 302, plus the 5th one that we don't know, divided by 5, and we want to make at least a C. So in order to solve this, I'm dividing by 5, so the inverse operation would be to multiply by 5. So greater than or equal to 350, that's 70 times 5, and now you've got 302 plus x. So 302 I'm going to subtract, and so x is greater than or equal to, so she could make a 48 or higher on this last exam in order to maintain her C. Now, if you wanted to do the same thing, notice to learn at least a B, there's just one thing that needs to change. And so in your formula is you're going to have your, you'll have your 78 and your 79 and your 72 and your 73 and the 5th score. All of that's going to be the same, except now if you want a B, it's going to have to be greater than or equal to 80. So the process still continues the same way. It's just the 80 would be this, you'd have to substitute that for greater than or equal to 80. All right, so these are just some examples, practice examples. So if we're using, if we want to graph this, so x is greater than -6, so I cannot include -6. And I want every value that's bigger than -6. That's what will work. That's what will make the inequality a true statement. That's what you're looking for. So if you pick a value over here like 10, is 10 greater than -6? Yes. Pick something over here, maybe -10. Is -10 greater than -6? No, and that's why we saw the shaded region here. Let's look at this next one. -2 is less than or equal to x is less than 3. So all the values are less than 3. See, all the values are less than 3, but they're all negative 2 is also smaller than all the values, less than or equal to. So we are going to include negative 2 because you see the bar underneath the less than sign. You don't see one here. That's why it's open. So what you're seeing is a conjunction, an intersection, and any number in between negative 2, including negative 2, and 3 will make this part B statement true. And then finally, x is less than negative 1, so I'm going to not include negative 1, but I want everything to the left of it. So here we've got x minus 7 is less than negative 12, so I'm going to add 7, just like I'm solving an equation. X is less than, now you got to be careful with your integers, negative 12 plus 7. All right, the signs are not the same, so you can subtract. 12 minus 7 is 5, and keep the sign of the larger absolute value. Negative 12 or 7, which one has the largest absolute value? Negative 12, so the answer is negative. So when you go to graph that, you're going to not include negative 5, but you want everything left of it. Let's look at B. 14 plus 2x is less than or equal to 3x. So I'm just going to move the 2x to the right side. And so I get 14 is less than or equal to x. Now that means 14 is smaller than all of the solutions. Or I could say x is bigger than all the solutions are bigger than 14. So these two mean the same thing. Notice I had to change the symbol if I put the variable on the right or the left. So I am going to include it at 14, but I know that all the values are larger than 14 if I look at that statement. But if I look at this statement, it just shows that 14 is smaller than all the possible. And then finally, we've got 4x plus 1 is greater than or equal to 5x. So if I subtract 4x, I've got 1 is greater than or equal to x, or that means x is less than or equal to 1. So that would be including it at 1 because it's greater than or equal to, or less than or equal to. And so all the values are smaller than 1, which also means here that 1 is bigger than all of the values. So x minus 7 is less than negative 12, so I'm going to add let's look at this one here. 8x is greater than or equal to negative 40, so I'm going to divide by 8. And so x is greater than negative 5. Negative divided by positive is negative. And so if you wanted to sketch, quick sketch, I'm going to include it at negative 5, and all the values are larger than negative 5. Part B. You've got 5x is less than or equal to negative 30. Divide by 5. You got x is less than negative 6. Included at negative 6, and I want every value smaller than negative 6. And then finally C, negative 4x is less than 32, so when you divide by a negative, we want to reverse that symbol, so it went from less than to greater than, and then what's a positive 32 divided by negative 4 would be a negative 8. And I want to not include negative 8, but I want every value larger. Okay, and then let's look at A. So I've got to distribute because I see the parentheses. This is going to put us with variables on both sides, so that'll be negative 3x. Negative 3 times negative 6 is a positive 18. Now variables are on both sides, so I'm going to subtract 2x, put the variables on the left. So this will be negative 5x plus 18. And then I'm going to subtract 18. So that'll be negative 5x is greater than, all right, this is a negative 2 and a negative 18. Think of it as negative 2 plus a negative 18 would be a negative 20 because the signs are the same. Divide by negative 5, and x is greater than 4. But I divided by negative, so I need to make sure that I reverse that symbol, and there it is. So, included at 4, everything to the left. Now let's make sure that something that makes sense. So something that's less than 4 that's equal to check would be 0. So if I substitute a 0 into this original, 0 minus 6 is negative 6. 2 times 0 is 0, 0 minus 2. All right, so I'm going to get 18 is greater than negative 2. True or false? It's a true statement, so that means the values work over here. All right, so let's look at B. Got 2/3 times 3x minus 1 is greater than or equal to 3/2 times 2x minus 3. So since I have, here's one way to do this. Since I see that I haven't distributed the numbers yet, the fractions, I could look at the denominators and I can see that I've got 3 and I've got 2. So I'm going to multiply by a least common multiple of 6. And that will multiply by this entire term and by this entire term. So what is 6 times 2/3? That's 12/3 times 3x minus 1 greater than or equal to 6 times 3/2 is 18/2 times 2x minus 3. So 12/3 is 4, so I'm going to multiply that by 3x minus 1. 18 divided by 2 is 9 times 2x minus 3. And I just need to distribute both sides, so that'll be 12x minus 4, and that'll be 18x minus 27. So I'm going to subtract the 18x. So that'll give me 12, take away 18 is negative 6x minus 4 minus 24. So I'm going to add 4. That's 27, sorry, that's 27 there. Add 4. So negative 6x is greater than or equal to, let me fix that. That was 9 times negative 3 right here is negative 27. And so when you add 4, signs are different, so you'll subtract, so you get negative. I'm going to add 4 to negative 27, so I get negative 23. And so I'm going to divide by negative 6, so I get x is less than or equal to 23/6. And if I sketch that, that's almost 4. And I want everything to the left. And because I divided by a negative, I had to reverse my inequality symbol. All right, so let's look at this last one. 7 times 4 minus x plus 5x is less than to 2 times 16 minus x. So we're going to distribute. So that'll be 28 minus 7x plus 5x is less than, distribute, 32 minus 2x. Like terms here, so that'll be 28 minus 2x is less than 32 minus 2x. And so when I add the 2x, I'm going to get 28 is less than 32. and that is a true statement. So that just means that any number that you decide to substitute in for x will work.